Good morning to all. I am Santosh, Assistant Professor, Department of Chemical Engineering, Erode Sengundar Engineering College. Today's lecture is about biodiesel production and their feedstocks. Right. Before proceeding to the topic, one should know about the alternate fuels. What is the necessity of alternate fuel? So there are various alternate fuels available, such as biogas, biohydrogen, biodiesel, etc. etc. So we are going to discuss about the biodiesel. So what is the necessity of going towards biodiesel? So there are two major reasons for that. One is the fossil fuels are getting depleted every day, and the increase of petroleum prices is a major concern. These two are the major reason for getting attracted towards that alternate fuel, right? So we should first chemically define biodiesel. So biodiesel can be defined as monoalkyl esters of long chain fatty acids that can be derived from vegetable oils, animal fats, or algae, and that should meet the requirements of ASTM standards, right? So we have seen what is the chemical definition of biodiesel. Likewise, we should also know what is not biodiesel. Blends of biodiesel and petroleum diesel cannot be called as pure biodiesel. Likewise, unprocessed fats and oils, mixtures or emulsions of alcohol and fats or oils, bio-derived fuels such as FT diesel, they all cannot be called as pure biodiesel, right? So coming to the biodiesel reaction. So there is a famous reaction called transesterification. So we should know about that reaction first. So biodiesel reaction involves the treatment of a alcohol with a vegetable oil or an animal fat or algae in the presence of a catalyst. So that should ultimately result in the production of biodiesel. So in this reaction, glycerol can be obtained as a byproduct. So the obtained product has to be water washed 2 to 3 times in order to separate out the glycerol, and we can obtain pure biodiesel, right? So this reaction ultimately needs a catalyst. So that catalyst can either be homogeneous or it can be heterogeneous, or it can be a biocatalyst also. Nowadays, the researchers are much attracted towards the usage of nanocatalyst due to various reasons. Since it has got major advantages such as high porosity and high surface area, the emergence of nanocatalyst is unstoppable. Next, we are going to speak about the sources of oils and fats. So the biodiesel sources can be classified into two different types. One is edible source, another one is non-edible source. Edible sources, for example, soybean oil, corn oil, take any other seed oil. Palm oil is one such edible source. So previously researchers used it to produce biodiesel only based on the edible oil. So what is the major drawback of edible oil means the cost of edible oil itself is very higher. For example, you take palm oil, it is costing around 70 to 75 rupees per liter. Once if we use edible oil and produce biodiesel, it ultimately results in the cost versus fuel, the cost availability versus fuel demand will come. So this is the reason for the researchers to switch over to the non-edible oil. In that way, non-edible oil has gained much more attention for the production of biodiesel. So, speaking about the non-edible sources, there are various sources such as Jatropha carcass, Ungamia pinnata, Swetinia magagoni, etc. etc. There are n number of sources available for non-edible oil. They have been used by the modern day researchers due to its various advantages. Likewise, beef tallows can be used, animal fats can be used, grease and lard can be used for the production of biodiesel. The famous source of biodiesel is algae. Since it has got higher advantages, many are shifting their attention towards algae. Right. So we have seen these various sources of biodiesel. Next is the quality requirements for standard biodiesel production. So here we need to speak about the free fatty acid content. So the free fatty acid content should be less than 2%. Likewise, the moisture content has to be below 0.1, that is the desired moisture content, and the permitted moisture content has to be less than 0.5%. So what about the phosphorus and sulfur content? It should be kept below 15 ppm in order to get a quality biodiesel, right? So what is meant by free fatty acids? So free fatty acids are weak organic acids with carbon numbers ranging from 8 to 22 or even higher than that. So they are naturally occurring. They are products of partial decomposition of fats and oils. They can be easily neutralized using alkali hydroxides for the manufacture of soap. So these FFAs can be converted to biodiesel typically using a mineral acid catalyst. Right. So now we are coming to the categories of biodiesel processes. There are many categories available. So first one is base catalyzed transesterification. So that base catalyzed transesterification can be carried out either in a batch system or in a continuous system. Second one is acid catalyzed transesterification. So this is otherwise called as a direct esterification process. For example, if the taken oil is having high amount of acid value, we need to do esterification in order to bring down the level of acid value of the oil. So that needs to be pre-treated. That is called as a FFA pre-treatment. That has to be carried out. Then only we can opt for the transesterification reaction. So acid catalyzed transesterification is a two-step process where we need to pre-treat the FFA and then we need to carry out the transesterification after the pre-treatment. Third one is non-catalytic processes. Here we can use two different types of methods. One is cold solvent process, another one is supercritical method. Right. So what are the key process variables that affects the transesterification reaction? There are various process variables available, right from temperature, pressure, methanol oil ratio, reaction time, mixing parameters. So the temperature, first one is temperature. The temperature has to be maintained accordingly. That should not affect the rate of transesterification. Likewise, the normal pressure range has to be altered. It should not disturb the rate of transesterification. Coming back to the methanol oil ratio, it is one of the important parameters which affects the rate of transesterification. So that has to be taken care. Likewise, time and mixing also needs to be altered from time to time. Right. This is the base catalyzed batch system. This picture shows the base catalyzed batch system where we are having a batch reactor, decanter, evaporator. Next is continuous CSTR system. Here we need to employ the continuous stirred tank reactor for the production of biodiesel. Next one is base catalyzed PFR system. Here plug flow reactor is being employed along with the flash evaporator. Other things are same as like the batch system. This is the heterogeneous catalyst system. Heterogeneous catalyst is nothing but it involves more than one phase. Right. Process conditions. First one is alcohol triglyceride ratio. As far as batch catalyst transesterification is concerned, the alcohol triglyceride ratio has to be kept in the range of 6:1 to 10:1. In the acid catalyst transesterification, the range of alcohol and triglyceride ratio can be varied from 9:1 to 40:1. Right. The second one is residence time. Here, this is a very important parameter. What is meant by residence time? First, we should know that residence time is the time taken by the molecule to pass through a particular vessel or a reactor. Right. So, in the base catalyst transesterification, the residence time has to be maintained in the range of 5 minutes to 4 hours. As far as acid catalyst transesterification is concerned, the residence time ranges from 15 minutes to 8 hours. Right. Next is biodiesel production chemistry. Here, we need to speak about the concept of esterification. So, it is a three-step reaction. Esterification is a three-step reaction. So, it pertains to the solubility, it deals with the rate of the reaction, and also production inhibition has to be seen in this biodiesel production chemistry. Right. Next is process conditions. First one is temperature. So once while we increase the temperature, the solubility also automatically increases. So what happens to the rate? Here the reaction rate doubles with the 10 degrees Celsius for every rise in the temperature. Right. So the pressure has to be kept in the range of 10 to 15 psi above the vapor pressure. Right. So how to select a particular system for the production of biodiesel? Either it can be a batch or it can be a continuous. In the batch system, it can be used for small capacity systems and the long residence time has to be maintained. As far as continuous system is concerned, it is meant for large capacity systems where we need to employ longer residence times by using CSTRs or PFRs. This residence time can be optimized using multiple parameters. Right. So here is the summary of this video lecture. Production of fatty acid esters is very easy, whereas production of biodiesel is a very difficult process. There are multiple ways to make biodiesel to meet multiple business models. There are multiple sources of fats and oils available for the production of biodiesel that can be adapted to the local realities. I hope you could have got some knowledge about the basics of biodiesel. What is the definition of biodiesel? What are all the production methods involved in the biodiesel? What is the major reaction that governs the biodiesel? What is the nature of the catalyst that has been employed for the biodiesel production? This is Santosh signing off. Thank you.